Good morning, guys. Long time no see. I want to go ahead and start today off with a recap of 5-4, which is all about the sum and difference formulas. So we're going to go ahead and get started today. If you guys could go ahead and take a look at this first problem. It says find the exact value of cosine of pi over 12. Now notice I went ahead and put the formulas right next to you so you can use those as your reference. Go ahead and take a pause and try to find the exact value without the use of a calculator. Okay, so hopefully you went ahead and started that. We're going to go ahead and start this now. First thing I want to do is I want to identify some sums or differences that are going to either add or subtract to pi over 12. That are some things that I do know on my unit circle. So some things that I do know on my unit circle would be like pi over 4. I know pi over 6. And I know like pi over 3. Okay, so if I think about, what are two things that I know that are going to add or subtract to pi over 12? Well, nothing on the unit circle is going to add to pi over 12 because if I think about pi over 12, it's smaller than pi over 6, smaller than pi over 4, and smaller than pi over 3. So I'm going to have to use subtraction here. So if I take a look here, if I say pi over 3 minus pi over 4, let's go ahead and see what that ends up being. So if I say pi, I want a little bit of a thicker pen. So pi over, nope, not white. Pi over 3 minus pi over 4. So hopefully this is going to bring us back to some awesome fraction days. In order to subtract these, I need to make sure I have the same denominator. So I'm going to multiply the first by the denominator of the second, and the second by the denominator of the first, which is going to give me 4 pi over, 12, that's what I want, minus 3 pi over 12. Well, that works out to be exactly pi over 12, which is good. So what I'm going to do is I'm going to replace pi over 12 with pi over 3 minus pi over 4. So we're going to say cosine of, so instead of saying pi over 12, I'm going to say pi over 3 minus pi over 4. So pi over 3 minus pi over 4. And the reason I'm doing this is I want to use sum and difference. So at this point, I want to go ahead and identify, hey, what is the sum and difference that best matches cosine of something minus something? Well, this is cosine of something minus something, so let's go ahead and rewrite it. So I'm going to have cosine, don't write it like that. I'm going to have cosine of A, we're going to say A is pi over 3. So pi over 3 times cosine of B, which is pi over 4, plus sine of A, which is pi over 3, times sine of B, which is pi over 4. So these are all really, really easy to evaluate because they're on my unit circle. So first one, cosine of pi over 3. Cosine of pi over 3 is a half. You can use your unit circle there. Cosine of pi over 4 is radical 2 over 2. Plus sine of pi over 3. Well, sine of pi over 3 is radical 3 over 2. Sine of pi over 4 is radical 2 over 2. Let's go ahead and multiply these and write this in simplest terms. 1 times radical 2 is radical 2. 2 times 2 is 4. Plus radical 3 times radical 2 is radical 6 over 4. And so what I get is radical 2 plus radical 6 all over 4. And that is one very simple application of the sum and difference formulas. All right, let's go ahead and move on to the next question. All right, so this one is extremely similar. It says find the exact value of sine of 75. So what I want to know is what are some things on the unit circle that add to 75? Well, let's talk about things in terms of degrees now. I know we haven't done this in a while. This right here is 45 degrees. This is 30 degrees. This is 60. Well, 45 plus 30 is 75. So I'm going to rewrite sine of 75, which is not on my unit circle, as two things that are. So we'll say 45 plus 30. All right, after that, I want to use the sum and difference formulas. So let's go ahead and find one that matches. Well, the sine of something plus something looks like the first one here. And so I'm going to rewrite this. This is going to be sine of A, which is 45, times cosine of B, which is 30, plus cosine of A, which is 45, times sine of B, which is 30. We're just going to use our unit circle to evaluate. Sine of 45 is radical 2 over 2. Cosine of 30 is radical 3 over 2. Cosine of 45 is radical 2 over 2. and sine of 30 is a half. All right, so I'm just going to go ahead and evaluate this. I get radical 6 plus radical 2 all over a common denominator of 4. All right, so that one is the exact same. Instead of being in radians, we are in degrees. All right, let's go on to the next question. All right, so it says find the exact value of cosine of u plus v. I'm so sorry, but this is how the book writes it. I know u's and v's look very similar. U plus v, if I know that sine of u is equal to 12 over 13, and that u is between 0 and pi over 2, and cosine of v is equal to negative 3/5, and I know that v is between pi over 2 and pi. Okay, first thing I want to establish here, I'm going to actually use two colors here. I know that sine of u is equal to 12/13, and I know that cosine of v is equal to negative 3/5. I'm going to go ahead and try to use the sum and difference formula here. So let me go ahead and paste my sum and difference formula in here. So the first thing I want to look at is, okay, I need to have cosine of something plus something. So let's get our highlighter out. Cosine of something plus something looks like this. So let's go ahead and just start off by replacing. So what I'm going to get is cosine of u, which is going to be a in this case, times cosine of v. I should put a little tail on the u so we don't get confused. And then we're going to say minus sine of a, which is u, times sine of b, which is v. Okay, so we can see right off the bat here, I know a couple of things. I know cosine of v is negative 3/5. So let's go ahead and replace that. And I also know that sine of u is 12/13. So I don't really have enough information, but I can at least write what I know. So that's 3/5 here. And that is 12/13 here. So the question is, how do I find the rest of the information? Well, the key to being successful in this problem is to draw a triangle. It is to draw a triangle. I know that that's maybe not what we want to hear, but that is basically our best bet. So if a sine of u is equal to 12 over 13, and u is between 0 and 2 pi, what that is saying is that u has to be in the first quadrant. U has to be in the first quadrant. It's got to be between 0 and pi over 2, which I realize you can't see that at all. It's got to be between 0 and pi over 2. Okay, well, let's draw a triangle. I'm going to make that triangle green. So we're going to go ahead and make that triangle green. Make sure I label it, but all of my U's are going to be green. And I think it's important that if you do have colors, you use them here because it does get a little bit confusing. Okay, so I have this triangle, and I want my triangle to be in the first quadrant. So let me try. I'm going to actually draw a circle first to make sure it's in the first quadrant. There we go. All right, so I have a triangle here. I know that it's in the first quadrant because it's between 0 and pi over 2. I know that sine is equal to y over r. So 12 over 13 is equal to y over r, which means my r value has got to be 13. My y value, my up and down value, is 12. And this looks like a classic 12, 13, 5. So this right here is 5 using just a Pythagorean triple. Okay, let's go ahead and do a different color. Let's do blue. And let's go ahead and map out cosine of v. Okay, I know some more information for this one. So for cosine of v, let's go ahead and we'll draw a blue circle here. It says that this triangle has got to be between pi over 2 and pi. Okay, well, let's see. Pi over 2 is here, and pi is here. So it has to be somewhere in this quadrant. It's got to be somewhere in this quadrant. So let's go ahead and draw a triangle in that quadrant. It doesn't have to be perfect. Something like that. Okay, so I know that cosine is equal to negative 3/5. So cosine is equal to negative 3/5. I also know that cosine is equal to x over r. So r is never negative. So r is going to be 5 in this case. And my x value is going to be negative 3, which makes sense because I'm in that second quadrant. So my x value should be negative. Well, this is actually a 3, 4, 5, so we actually don't have to do too much work here. You could derive that using Pythagorean identity. Sorry, not identities. You could verify using a Pythagorean triple. All right, so at this point, we have pretty much everything we need to know. This blue triangle is the U triangle, blue U. And the green is V, V. I don't know if that actually rhymes, but I thought it was kind of fun this morning. Okay, so what we're, oh, no. I almost messed all of us up this morning just because I liked rhyming. It says sign of U is green. So green is actually U. That's no fun, but it is. All right, so green is U and blue is V. Blue is V. Okay. Let's go ahead and find the final total here. So cosine of U right here. Why am I doing, it's because I said blue is U. That's why. All right, cosine of U, which is green. I'm going to make that one green because it has a U in it. And then we'll say sine of V. We're going to make that blue because it has a V in it. All right, let's go ahead and use our triangles to evaluate. Okay, cosine of U. Cosine is equal to adjacent over hypotenuse. It's equal to x over r. So that's going to be 5/13. So I'm going to get 5/13 times -3/5 minus, all right, let's see. We got ourselves 12/13 already. Sine of V, that's the blue triangle. Sine is equal to opposite over hypotenuse, or y over r, which is going to be 4/5. It's going to be 4/5. So let's go ahead and evaluate this here. All right, so I'll just go ahead and evaluate this in black. All right, so I'm going to get -5 times 3 times 5 times -3 is 15 all over 65. Minus 12 times 4 is 48 all over 65. If I subtract the 2, I'm going to get 33. Yep, over 65. And so the answer here is 33 over 65. All right, let's keep going. We'll go on to our next question. All right, next question. It says, write sine of the arctangent. Ooh, I know this problem. Sine of the arctangent of 1 plus arc cosine of x. This definitely requires a triangle. So now that we're out of the Christmas season, we'll go back to the blue and gold because go Blue Devils. Let's go ahead and we'll highlight this first arctangent in blue and we'll highlight arc cosine in yellow. I'm going to make 2 triangles here. I'm going to make 2 triangles. First, I'm going to have a blue triangle that's going to represent arctangent of 1. All right, so arctangent of 1, we're going to say, let's say we start here. It doesn't really matter where we start. I know that tangent is equal to, y over x. So tangent is equal to y over x. So I could say that tangent in this case is equal to 1 over 1 technically. So y and x are both going to be 1. So y and x are both going to be 1. Well, if both y and x are 1, let's use Pythagorean identity to find the other side. So I'm going to get 1 squared plus 1 squared is equal to r squared. And so the square root of 2 has got to equal r. So this right here is the filled out triangle. All right, let's go on over here and we'll fill out a yellow triangle. We're going to fill out a yellow triangle. All right, so arc cosine of x. So remember, if cosine of x, that's the same thing as me saying the arc cosine of x over 1. X over 1 arc. Remember that cosine is equal to x over r. So in this case, we can say x over 1 is equal to x over r. So my r value is going to be 1. And we can say that our x value is still just going to be x. So I want to know what's this other value here. So if I say question mark squared plus x squared is equal to 1 squared. And remember, I'm going to solve for that question mark. Question mark squared is equal to 1 minus x squared. And so the question mark is equal to the square root of 1 minus x squared. And so the y value here, that opposite value, is equal to the square root of 1 minus x squared. All right, now we have enough to figure out the answer. Let's go ahead and put our identities in here. I know that this is the sine of something plus something. That's the sine of something plus something. So let's go ahead and find that. Sine of something plus something. I can rewrite this as the sine of, and let's try to keep colors here because I'm going to get confused, a, which is arctangent of 1. So sine of A times the cosine of B. In this case, that is the yellow. That's the arc cosine of X. And then we're going to say plus the cosine of A. Cosine of A, and in this case, A is blue, so that's arctangent of 1. I run out of room here. Oops. And then we're going to say times sine of B. In that case, that is going to be the yellow, which is arc cosine of X. All right, so we're so close to the answer here. Just bear with me. First one, sine of arctangent of 1. That's basically saying, hey, what is sine of the blue triangle? Sine of the blue triangle is going to be equal to opposite over hypotenuse. So that's going to be 1 over square root of 2. Cosine of arc cosine. These two are inverses, so they're actually going to cancel out to just being X. Plus cosine of arctangent. So I want to know, hey, what's the cosine of the blue triangle? Well, cosine is equal to adjacent over hypotenuse, so that's going to be 1 over the square root of 2. And arc cosine, sine of the arc cosine of X. That's the same thing as me saying, hey, what is the sine of the yellow triangle? All right, well, sine of arc cosine of X, that's going to be a sine value. So sine is equal to opposite over hypotenuse. So that's going to be the square root of 1 minus x squared over 1. So if I simplify this, I get x minus the square root of 1 minus x squared all over a common denominator of radical 2. And that right there is the solution. All right, I know this is a long video, just one more question for you. All right, so it says find all of the solutions of this equation here. So I want you, using the sum and difference formulas, try your hand at finding all of the solutions to this equation here. All right, so if we go ahead and start with this, you can probably see right off the bat that some things are going to cancel here. And so the first thing that's going to cancel here are these and these. So let's go ahead and combine what are like terms. We're going to get 2 sine of x cosine of pi over 4. Remember, cosine of pi over 4 is just a number. Let's go and evaluate that. Cosine of pi over 4. And I realize now I probably did the first step for you because if you can see this first step here, is probably the result of a sum and difference formula. So I guess you don't need your sum and difference formulas right now. Cosine of pi over 4 is going to be radical 2 over 2 because its ordered pair is radical 2 over 2, comma radical 2 over 2. So I'm going to get 2 times sine of x times radical 2 over 2 is equal to negative 1. If I multiply these out, these 2's are going to cancel. So I have radical 2 sine of x is equal to negative 1. So sine of x is equal to, let's divide by radical 2, divide by radical 2. I'm going to get negative 1 over radical 2. Don't really recognize that. Don't really remember that being on my unit circle. So I'm going to rationalize and see if I get anything that I do recognize. I'm going to multiply by radical 2 over radical 2, which is going to give me a result of negative radical 2 over 2. Ooh, that does happen on my unit circle. The question is, when does sine of x equal negative radical 2 over 2? Well, let's go on my unit circle and find out, hey, when do I have an x value of negative radical 2 over 2? That happens here and it happens here. It happens at 3 pi over 4 and it happens at 5 pi over 4. And so the official solution here, and it did not give me an interval at all, so I'm going to have to write this generically. I'm going to get 3 pi over 4 plus the period, which is 2 pi n, and I'm going to get 5 pi over 4 plus the period, which is 2 pi n. And that right there is the solution. So sorry this video got so long, but I hope this is a good recap of 5-4b.